Good afternoon. Again, you're back here due to corona issues. We have to do this. You have to stay safe, but still learn chemistry. Today, we want to jump to Form 2 work in chemistry, more specifically salts. And I want us to discuss salts. Just to begin with, I'll write two equations that will help us define what a salt is. So, definition. We'll use two equations. The first equation would be zinc metal reacting with 2 moles of hydrochloric acid to form 1 mole of zinc chloride and hydrogen gas. This is the first reaction we'll use to define salt. And the second equation we'll use to define salt will be a reaction between sodium hydroxide plus hydrochloric acid, more ratio 1:1, forms sodium chloride and water. Now we are going to use these two equations to talk about what salt is as an introductory to this topic. In the first equation, before the reaction, if you look at the reagents, next to the chloride ion, there is hydrogen. But after the reaction, next to the chloride, what we have is zinc metal. And the hydrogen has been displaced. So from this equation, our salt is here. This is the salt. This is the acid. This is the metal. So how do we use this equation to define salt? We can say from this equation that this salt here is an ionic compound. An ionic compound. Formed when the hydrogen of an acid, is directly, or it also could be indirectly, displaced by a metallic ion like in this case the metallic ion is zinc. But remember, we also have ammonium salt, so we can say or an ammonium ion. That marks the first definition of what a salt is. So we can define a salt as an ionic compound formed when the hydrogen of an acid is displaced by a metal ion or an ammonium ion. Because before the reaction, we are seeing there was a hydrogen next to the Cl in the acid. But after the reaction, the position of H is taken by zinc. And so we are seeing hydrogen ions have been displaced by zinc to form the salt. Then in the equation number 2, our salt is sodium chloride. And in the sodium chloride, we have the cation there. Then on the other side, we have the anion. Now the question we have is, if we look at these two reagents, one of them being the base, that is sodium hydroxide, and we look at the acid here, hydrochloric acid, then we can recognize the fact that the cation sodium actually originated from the base. And if you're keen enough, we will discover that the anion, that is the chloride came from the acid. So we can conclude by saying that the second equation can help us define a salt as an ionic compound that is formed when the cation from a base combines with the anion from an acid. Because from the look of this, we are seeing the chloride, which is in the salt, originating from the acid. And again, we are seeing the cation, which is the sodium, from our reagents, it originates from the base. So from this equation, we can conclude that a salt is an ionic compound formed when the cation from a base combines with the anion from an acid. So we have two definitions, both of them correct. So if you're taught to define a salt, you pick one that you can remember easily. But to help you remember an equation of the reaction between zinc metal and hydrochloric acid. You can also remember an equation of the reaction between sodium hydroxide and hydrochloric acid. So the two equations can quickly give you the definition of what a salt is. So we are saying in the first equation, a salt is an ionic compound formed when the hydrogen of an acid is directly or indirectly displaced by a metallic ion or an ammonium ion. That is zinc chloride for this case. And the second equation, that is sodium hydroxide reacting with hydrochloric acid, gives us sodium chloride and water. That is a salt and water. Our salt is sodium chloride. If we look at sodium chloride, it has two parts. It has the cation and the anion. The cation, if we follow the equation from the reagent side, we're discovering that the cation came from the base, that is sodium hydroxide, and the chloride came from the acid, and the acid is dilute hydrochloric acid, shown there. So we can conclude, we are saying we can conclude that a salt is actually an ionic compound formed when the cation from a base combines with the anion from an acid. I hope that is very clear and everybody is getting what I'm talking about. That makes us move to the next stage. Now that we know what a salt is, we can talk about something else here. So after knowing what a salt is, we can discuss the types of salts we have. And the types of salts here are actually based on composition. So we talk about types of salts. Types of salts. Types of salts. Types of salts. Now we have 4 types of salts, and I'm saying the types here are based on composition. composition. And when I say composition, I don't mean English composition writing. What I actually mean is what they're made of. The first type of salt we'll talk about here, type number 1, is what we call acid salt. Acid salt. Acid salt. Acid salt. Now, what is an acid salt? We are not saying that it is acidic salt. Mark that. We don't say acidic salt. We say acid salt. What makes acid salts acid salts? We can define acid salts as salts that contain replaceable hydrogen atoms in them. So if a salt contains replaceable hydrogen atoms, then we say it is an acid salt. Here we have examples. Examples of acid salts we have include sodium hydrogen carbonate. Sodium hydrogen carbonate. Number 2, we have potassium hydrogen sulfate. And from the look of things, the trend is very clear. The first one we are seeing here, sodium hydrogen carbonate. The hydrogen we are talking about that makes it be called an acid salt. And the other one has, that is potassium hydrogen sulfate. Also a replaceable hydrogen atom you're talking about. So these hydrogens here are what makes these salts be called acid salts. After this, we have the second type. And the second type, which is actually the opposite of this. Second type of salt we have is what we call normal salt. Normal salt. Normal salt. They're defined oppositely, and we can say are salts that do not contain any replaceable hydrogen atoms. Examples of such salts, examples of normal salts, examples of normal salts include include the first one, sodium chloride. Also include potassium sulfate. So could also talk about sodium nitrate. If you look at the formulas, you will discover there is no irreplaceable hydrogen. Sodium chloride, potassium sulfate, and sodium nitrate. Any salt that is of that nature that has no replaceable hydrogen atoms is said to be a normal salt. That takes us to the third type, and the third type is what we call basic salts. Basic salt. Basic salts. Basic salts. Basic salts. Basic salts. So number 3, we are seeing basic salts. What are basic salts? Now, just from the word basic, we can define them and say are salts that contain the hydroxide Some books will talk about hydroxyl ions in them. So it is the hydroxide ions or the hydroxyl ions in them that makes them be called basic. And so we are seeing examples of basic salts. Examples of basic salts include basic zinc chloride, we have basic calcium chloride, we have basic copper carbonate, and we have basic magnesium carbonate. The three salts here, we can see from the formulas, basic zinc chloride can be written that way as zinc hydroxide there, Cl. Same applies to calcium, can be written in that form, calcium hydroxide, Cl. Talking about basic copper carbonate, we can talk about actually a double salt, also malachite, main constituent, we say, Cu dot Cu hydroxide. And we have also magnesium carbonate, basic. There is a dot there showing that it is also a double salt. That is MgOH2. Double salt because of the fact that they have the hydroxide in them. So it is the presence of the hydroxide ions that make these salts be called basic. Make these salts be called basic. And that takes us to salt type 2. Salt type 2. And the salt type 2 we have, sorry, not type 2 but type 4, a very unique one. And type number 4 is what we call double salts. Double salts. Double salts. Double salts. What are double salts? Double salts are salts that contain two different cations or anions. You're saying salts that contain two different cations or anions. What do we mean by this? Maybe the examples will show. Examples of double salt include, we can talk about number 1, trona. Trona has the formula sodium carbonate dot sodium hydrogen carbonate dot 2H2O. Why is it a double salt? It is a double salt because of the fact that it has two anions. The first anion is the carbonate. The other anion we have is the hydrogen carbonate. That is what makes it a double salt. The second example is a normal double salt we use, more so in the redox titrations. We call it ammonium ion 2 sulfate. Ammonium ion 2 sulfate is a double salt. The formula shows it very clearly. We have Fe, then we have NH4 2. We also have SO4 2.6H2O. In some books, this is just written as iron sulfate dot ammonium sulfate dot 6H2O. What are we talking about here? What makes it a double salt is the fact that it has two cations. The cation, the first one you're talking about, is iron 2, and the other cation is the ammonium ion, ammonium radical. So we are seeing they are double salts because they contain either two different cations or two different anions. And that marks the end of types of salts that is based on composition. Based on composition. Based on composition. We have other types of salts, yes. And the other types of salts we have are salts but based on their properties. We have three classes of salts based on their properties, and the classes, we can name them here. So we have salts that is types of salts based on properties of the salts. Properties of the salts. Properties of the salts. These types are three. Type number 1 is what we call the hygroscopic salt. We have number 2, the liquescent. Salts. And lastly, we have the efflorescent salts. To begin with, let's talk about hygroscopic salts. Hygroscopic salts. Hygroscopic salts are salts which, when left exposed in air overnight, absorb moisture and become damp. Become damp. In other words, wet. But do not form solutions. But do not form solutions. Do not form solutions. But do not form solutions. We have examples of salts here, and the example of salts in this category we call anhydrous. We have one example, anhydrous. Copper 2 sulfate. We also have number 2 example, anhydrous cobalt 2 chloride. Cobalt 2 chloride. Cobalt 2 chloride. Apart from these, we have salts such as table salt, the table salt. And table salt is not purely sodium chloride, but a mixture of sodium chloride and magnesium chloride. It is actually the magnesium chloride in it that makes it hygroscopic. Magnesium chloride that makes it hygroscopic. This takes us to another level. So when we talk about hygroscopic salts, this process of absorption, of moisture becoming damp and not forming solution, is known as hygroscopy. So if the examiner talks about a process, the process is hygroscopy. But when the examiner talks about hygroscopic salts, then we are talking about the substances. Now, apart from salts and their nature as hygroscopic, we also have other substances that are not salts but still hygroscopic. A good example of hygroscopic substances that are hygroscopic include concentrated sulfuric acid. It's not a salt, but hygroscopic in nature. Not a salt, but hygroscopic in nature. For today, because of time, I may end at number 2 type, where we talked about deliquescent salts. What are deliquescent salts? Chloride. That is Cl2. These are salts that are said to be deliquescent. 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 So the process by which they absorb moisture and form solution is a process known as deliquescent substances absorb moisture through a process known as deliquescence. That is the name of the process by which they absorb moisture. Now, in our next class, we'll discuss. The last type in terms of the properties of the salts, and that is efflorescent salts. Efflorescent salts. After which we'll talk about methods of preparation of salts. Methods of preparation of salts. Otherwise, thank you. Corona is still there. I would say there, be safe. Keep safe, but at the same time, study chemistry. Thank you. That was my time. I'm Stephen Aira Juma, a teacher of maths and chemistry. Be blessed.